In this video, we will be looking at a few basic differentiation rules, and then I will work a few examples to illustrate those rules. Our first rule is called the constant rule, and it says that the derivative of a constant is equal to 0. Now, to get an intuitive feel for this rule, if you let our function be f of x equal 3, this is the same as y equals 3, which is a horizontal line through 3. Now recall that the limit definition of derivative, we went on to say that the derivative is just the slope of the graph of our function. And we know that the slope of a horizontal line is 0. So that just gives us an intuitive feel for f prime, which is slope for a constant function, is equal to 0. Our next rule is called the power rule. And this rule states that if you wish to find the derivative of an exponential, x raised to some power, all you need to do is take that exponent and bring it out as a coefficient in front, and then multiply that by the base x raised to the power decreased by 1. Now in this example, in order to use our power rule, we need to remember that when the exponent is not visible, it's 1. So our power rule says that the derivative of this function is equal to that exponent brought out front as a coefficient, and then multiplied by that exponent reduced by 1. So our derivative of f of x is equal to x to the 0, which we know is 1. Our next example, we'll just use our power rule straight. F prime is equal to, the rule says take that exponent and bring him out in front as the numerical coefficient. And then I'll have x raised to the 2 subtract 1. So our derivative of f of x in this case is 2x to the first power, or 2x. Our next example, this is 2 multiplied by x to the 10th power. This 2, we're not going to do anything with it as far as finding the derivative, except to keep it there. So my derivative, g prime of x, is going to be 2 multiplied by, and then the derivative of x to the 10th power, I can use the power rule on that. I'll bring the 10 out in front as the coefficient of my exponential, and now my x is raised to the 9th power. Remember, you just decrease the exponent by 1, and that's the new exponent. So do the math here, we see that my derivative of the g function is 20 multiplied by x to the 9th. On this next example, in order to use the power rule, we want to do a little rewriting. First of all, this x, I want to write that with an exponent. So I'm going to rewrite my h function as x to the first power, and then we know that we can bring this x that's in the denominator, we can bring that up to the numerator by just negating the exponent. So this is the same as 4 multiplied by x to the negative 1 power. The rule that we used on that one was x to the negative 1 equals 1 over x. Now both of these terms are written with exponents, and I can use my power rule. So my derivative is 1 multiplied by x to the 1 subtract 1. And then let's save that for a minute and go ahead and do a derivative on the second term. I have 4 multiplied by, and then this negative 1 is brought out in front of my exponential, and then x to the original exponent subtract 1. So my derivative now, I can just simplify this. It's going to be x to the 0, and then 4 times negative 1 is negative 4, and x is to the negative 2 power. I would probably rewrite this with this x factor down in the denominator. So my derivative is going to be x to the 0 is 1, subtract 4 over x squared. My next example, I'm going to do some rewriting so that it's made ready for the power rule. First thing that I'm going to do is simplify this and write it with an exponent, this denominator. So I can see that r of x is equal to, let me just copy this, x squared minus 3x plus 5. And I'm going to use the rule that when you have a radical, let's say x to the a power, and then the index on your radical is b, that radical can be rewritten with a fractional exponent. By first, your base is x, keep that base, and your exponent is going to have a numerator of whatever the power is, and a denominator, whatever the index on the radical is. So this is the rule that I'm going to apply right here for this bottom. My power on my radicand here is 1, since it's not visible. My index on the radical, since its square root, is 2. So this square root of x that's in the denominator, I can rewrite that as x to the 1/2. Now, what I want to do, so that I can use the power rule again, is I want to split this one big fraction into 3 separate fractions. So I'm going to take this fraction, and then I'm going to take this one, and then I'm going to take this last one. So rewriting still, I haven't even started with my derivative yet. I have x squared over x to the 1/2 minus 3x over x to the 1/2 plus 5 over x to the 1/2. Right, now I'm going to use the rule that if you have x to the a over x to the b, that's the same as x to the a minus b, to rewrite each of these so they're not fractions. My function now is x to the 2 subtract 1/2 minus 3 times x to the 1 subtract 1/2 plus 5 times x to the negative 1/2. So still writing my function in simpler terms so I can use my power rule. I need to subtract these two numbers. 2 is the same as 2 over 1, which is the same as 4/2. So we have x to the 4/2 minus 1/2 will be x to the 3/2. Subtract 3, x to the 2/2 subtract 1/2 will be 1/2. And then just copy this one. Alright, now I have 3 terms and they're each powers, so I can use the power rule. My derivative r prime is going to be, take this exponent out in front as the numerical coefficient, and then reduce the exponent by 1. 3/2 minus 1. Subtract 3 times the derivative on this one. Bring your 1/2 out in front, and then multiply it by x to the 1/2 minus 1. Plus 5 times, bring the exponent out in front, and multiply it by x to the negative 1/2 subtract 1. So this is my derivative. I just need to do some simplifying. R prime is 3/2 x to the 3/2 minus 2/2 is 1/2. Now I'm going to multiply these two factors together. Negative 3 times 1/2 is a negative 3/2. And then x to the 1/2 subtract 2/2 is going to be a negative 1/2. I'll multiply these two factors together. 5 times negative 1/2 is negative 5/2. And then x raised to the negative 1/2 subtract 2/2 would be a negative 3/2. Now this is our derivative. Be aware that you can write this in different forms. You can go ahead and put these all in radicals because they are fractional exponents, and remember that denominator indicates the index on the radical. So since these denominators are all 2, these are all square roots. Also the negative exponent, I could bring that factor down to the denominator if I wanted to. But right now let's just focus on finding the derivative. So that would be the derivative of the function r.